Hello everyone. On this video we will be looking at positive and negative numbers. Okay, so before we jump into that, we're going to look at your inequality symbols. Okay, you have your less than, your greater than, your less than or equal to, and your greater than or equal to. Okay, so for example, if you have 3 is less than 5, that reads as 3 is less than 5. You have 2 is greater than 1, of course reads 2 is greater than 1. You have 4 is less than or equal to 4 reads 4 is less than or equal to 4. That means that 4 can be either less than or equal to the number on the right. And you have 9 is greater than or equal to 8, which is 9 can be either greater than or equal to 8. In this case, it's greater than. Okay. So if you notice also, the inequality symbol always points to the smaller number when you're looking at the less than or greater than. Of course, with the less than or equal to or greater than equal to, it could be equal. But for the less than or greater than, it always points to the smaller number. So 3 is less than 5, it's going to point to the 3. 2 is greater than 1, is going to point to the 1. Okay, so that's one way to remember it. Okay. But just because it's written as an inequality doesn't mean it's always true. So let me go ahead and scroll that down a little bit. So if you have a statement like, well, statement or expression, depending on how you want to describe it, 0 is greater than 55. Okay, we know that's not true. 0 is not a larger number than 55. So in this case, we're going to call that a false statement or false expression. All right. Okay, so now we're going to kind of describe these on a number line. Okay, let me move that up. Okay, now your 0 is what we call your origin. Okay, that's where everything's starting. Okay, now going to the right, we're going to count like we normally would. You have your 1, your 2, your 3, your 4, your 5, your 6, your 7, your 8. And instead of writing all that down, we just know it's going to keep on going all the way to infinity. Okay, now starting at your origin and going to the right is your positive direction. Okay, so those are all the numbers we're used to using when we're counting things. Okay, now if you look at the other direction, again, we're going from 0, we're going to go from -1, -2, -3, -4, -5, -6, -7, -8, and it keeps on going all the way to negative infinity. Okay, now starting at the origin and going to the left, that's your negative direction. Okay, so now we have all our positive numbers and negative numbers. Now we can also use these for fractions, decimals. So let's say if we went to the right and we stopped right here, about halfway between 0 and 1. That could be positive 1/2 or positive 0.5. If we went and we stopped right here, that could be negative 1/2 or negative 0.5. So these are just the whole numbers. It doesn't mean that values in between them don't exist, because they do. Okay, so you can have negative 3.5 be right here between the 3 and the 4, or negative 3.5. Same way you could have positive 5.5 be between the 5 and the 6. All right, so again, these are just the whole numbers. You can expand on them an infinite number of ways. All right. So if you are still writing, of course, feel free to press pause and finish up. But we're going to go ahead and move on to our next page. Let me move that over. cover up down here just like that. Okay. Okay, we're going to look at the absolute value of a number, which is going to be really important going forward for our integers. Okay, so the absolute value of a number is the distance that number is from the origin on a number line. Okay, so to give you a couple of examples, the absolute value of 6. Okay, so if we start at our origin, remember that's our origin, how far is 6 away from the origin? 1, 2, 3, 4, 5, 6. So the absolute value of 6 is equal to 6. Okay, what about the absolute value of -6? Well, if we start at our origin, the distance from the origin to -6 is 1, 2, 3, 4, 5, 6. It's 6. What if we have the absolute value of 4? Okay. How far is 4 from the origin? Well, 1, 2, 3, 4. The distance of 4. What about the absolute value of -4? How far is that from the origin? Well, it's 1, 2, 3, 4. It's 4 units from the origin. Okay. So if you noticed here, the absolute value is always positive. Okay. Now, that doesn't take into account if it's a negative number on the outside of the absolute value. So what if you have, let's say, well, we'll do that on later examples. I don't want to jump ahead, which is what I was getting ready to do. I'm not going to jump ahead. We're going to cover that a little later. Okay. So again, you see the absolute value is always positive. Okay. Now, if you notice here also, you have 6, the absolute value of 6 and the absolute value of -6. They're both the same distance from the origin. Same with 4 and -4. They're both a distance of 4 from the origin, which brings us to our next statement. When two numbers are the same distance from the 0 or the origin on a number line, but in opposite directions, they are called opposites. Okay, so it's not too bad as far as thinking of what opposites are. So what if you have 6 and you have -6? Well, same number, but different signs. They are opposites. What if you have -8 and +8? Again, same number, just different signs. One's positive, one negative. They are opposites. Okay, so let's say if we have the opposite of -2, we're going to write that as the opposite of -2. Okay, so what's the opposite of -2? That's just 2. So the opposite of -2, we just write it this way, but we still get the same answer of 2. Okay, so the opposite of 5 is just the opposite of 5. So the opposite of 5 is negative 5. Okay. So how about you solve this one using this same method here? What if you have the opposite of negative 15 is, and I'll underline it for you to fill it out. Okay, so if you have to press pause, but it shouldn't take you too long to fill that out. The opposite of negative 15. Okay, so we know that's the opposite of negative 15. The opposite of negative 15 is positive 15. What about the opposite of positive 12? Okay, again, if you have to press pause to solve it, go ahead and press pause. Okay, so the opposite of 12 is the opposite of 12, which is negative 12. Okay, so mainly I wanted you to see how the opposites could be written more than one way. Okay, it's not always just going to be positive and negative. Plus, this comes up in a later video when we're looking at adding and subtracting positive and negative numbers. Okay, so this is very, very important here. Okay, along with the absolute value. So you want to make sure you understand those. All right, so if you are still writing, of course, feel free to pause it and finish up. But we're going to go ahead and move on to our next page, which brings us to the rule of absolute values. Okay. Now, there are lots of rules of absolute values. Well, not lots, but there are a couple. But we're going to mainly focus on this rule. Okay. So the rule of absolute values states that the absolute value of x can have two different solutions. The absolute value of x is equal to x when that number x is greater than 0, or it's positive. Or the absolute value of x can equal negative x when that x is less than 0, or negative. I know what you're thinking. You're probably thinking, wait a minute, you said the absolute value is always positive. So how can it equal the opposite or the negative of x? I'll show you. Okay, what if we let x equals 7? Now we can say that pretty confidently that 7 is positive. Okay, so since 7 is positive, our x is greater than 0, we're going to use this solution. So we know the absolute value of x equals x when x is greater than 0. Okay, this is positive. Okay, so that means the absolute value of 7 is equal to 7 when, well, not when, but since seven is greater than 0. Okay, all we did was replace our x with 7. Okay, but what if we let x equal negative 7? Okay, or the opposite of 7. Okay, well, since x is negative, we're going to use this second one. Absolute value of x is equal to negative x since x is less than 0. Okay, so the absolute value of x equals negative x when x is less than 0. And you have the absolute value of negative 7 equals the opposite of negative 7. What's the opposite of negative 7? It's 7. So the absolute value of negative 7 is equal to 7, since negative 7 is less than 0. Okay, so that's the rule of absolute value. Well, one of the rules of absolute values. Again, we're not going to go into all of the other rules because they don't really apply here, but you'll learn them later on. But as long as you understand this one, this is the main one, all the other rules of absolute values should make sense. All right, so if you're still writing this, feel free to press pause, but we're going to go ahead and jump into some more examples. Oops. Oh, it's falling. There we go. All right. So I want you to fill in the blank using the inequality less than or equal to, well, less than or greater than. We kind of left out less than or equal to or greater than equal to. Okay. You have 4 and 7. Is it less than or greater than? You have 5 and negative 2. Is it less than or greater than? You have 8 and negative 8. Is it less than or greater than? Negative 5 and 5. Negative 20 and negative 5. And negative 10 and negative 3. Now here's a hint. You can use the number line if you want to, until you get comfortable enough to not worry about using the number line. But this, again, if you're just getting started, the number line is your best friend because it can help you visualize it a little bit better. Okay, so again, just starting at your origin. I went from the origin to 10, and those 3 little dots just mean it's going to keep on going forever. And then I went from the origin to negative 10, and then I used those 3 little dots to take it all the way to negative 20 because I didn't have enough space to put the actual negative 20. So just imagine this goes from negative 10, and everything else between there is your negative 11, negative 12, all the way to negative 20. All right, so go ahead and press pause and try these on your own. All right, so I'm assuming you've paused it, so let's go ahead and verify your answer. Excuse me. Okay, so for A, you have 4 is what? Then 7. So if you look at it here, here's a hint. The number on the right is always going to be larger than the number on the left. So you have 4 and 7. 4 is going to be less than 7 because 7 is on the right. So 4 is less than 7. You can probably figure that out without the number line. But when you get to the negatives, the number line helps a lot. Okay, so for B, you have 5 and negative 2. So you see 5 is on the right, negative 2 is on the left. So negative 2 is less than 5. Or 5 is greater than negative 2. Okay, C, you see 8 and negative 8. Okay, so you see 8 is on the right, negative 8 is on the left. So 8 is greater than negative 8. Okay, so you see D. You have negative 5 and 5. You see negative 5 is on the left and 5 is on the right. So we know that negative 5 is less than 5. Now this is where it can get confusing and the number line helps. Negative 20 and negative 5. So if you notice, negative 20 is here and negative 5 is here. So since negative 20 is on the left, we know that negative 20 is less than negative 5. Okay, it's real easy to look at negative 20 and think it's a bigger number, but it's not. Negative 20 is actually a smaller number than negative 5. Think of it this way. Would you rather owe someone $20 or $5? I'd rather owe them $5 because owing somebody $20 means you're in bigger debt. So negative 20 is less than negative 5. Okay, so what about negative 10 and negative 3? Same thing. Negative 10 is on the left and negative 3 is on the right. So negative 10 is actually less than, oops, forgot to write down, negative 3. Let me move this over. Okay, so again, the number line isn't necessary, but it does help you get an understanding, and it's useful until you get really used to it. Once you get really used to it, then I wouldn't worry about drawing the number line after that. All right, so if you are still writing, of course, press pause and finish up. But we're going to go ahead and move on to our next example. Oops, wrong one. Let me separate the papers here. There we go. All right, there we go. Now we want to fill in the blank using the inequality symbol, again, less than or greater than. Okay. So, again, I want you to press pause. And I want you to try these on your own. Again, you see they're a little bit different than the ones before, but I want you to try those on your own. All right, I'm assuming you've paused it and worked it out. So let's go ahead and verify. Okay, so for problem A, absolute value of 8 is what to negative 2? Well, we know the absolute value of 8 is equal to 8. So 8 is what to negative 2? 8 is greater than negative 2. Okay, a positive number will always be greater than a negative number. You don't really need the number line for that one. When the signs are different, a positive number will always be greater than a negative. All right. So for problem B, negative 5 is what to 3? Well, we see here, what's the opposite of negative 5? The opposite of negative 5 is 5. So 5 is what to 3? 5 is greater than 3. Okay. So what if you have the absolute value of negative 2 is what to 0? Well, the absolute value of negative 2 is what? 2. The absolute value is always going to be positive. So that's going to be what to 0? 2 is greater than 0. Okay, so what if you have the negative of the absolute value of negative 8 is what to negative 4? Okay, this is the one that I was going to kind of introduce you to before, but I said I'll wait. I didn't want to jump ahead by putting a negative outside the absolute value. This is why I didn't want to do it then, because I'm going to show you why that is now. Okay, so if you notice here, since the negative is on the outside, we're just going to solve what's in here. Okay, so we bring down our negative. What's the absolute value of negative 8? Well, the absolute value of negative 8 is just 8. Okay. See, here our negative is on the outside, so what's the opposite of 8? The opposite of 8 is negative 8. Okay, and negative 8 is what to negative 4? If you use your number line, you see that negative 8 is less than negative 4. Okay, so that's how we use our opposites and negatives and positives and all of that. Okay, so hopefully this made sense, and I'll see you on the next video.